After a 9-year journey through the solar system, NASA's New Horizons spacecraft reached Pluto, capturing and transmitting the initial images of this distant world. This revelation astounded us considering Pluto's complex history. Once acknowledged as the 9th planet in our solar system, it underwent reclassification, debates, and speculation, remaining a blurry dot even through our most advanced telescopes. Now, over 80 years since its discovery, we possess the first detailed images of Pluto. Welcome to Spaceverse, where the wonders of the cosmos come to life. Join us on an extraordinary journey through the vast expanse of space, exploring the mysteries of celestial bodies, groundbreaking space discoveries, and the captivating stories that unfold in the great cosmic tapestry. Subscribe now and let the exploration begin. The spacecraft unveiled a Pluto adorned with geological features, hinting not only at a history of activity but also the potential for ongoing dynamism. The presence of towering mountains, deep valleys, and vast plains suggested a planet in a state of transformation, challenging the notion of it being a fossilized relic from the past. The most astonishing revelation was the compelling evidence of a subsurface ocean beneath layers of ice. This discovery prompted a re-evaluation of Pluto and opened new avenues for considering the existence of life beyond Earth. The notion that a seemingly lifeless planet on the outskirts of our solar system could house an ocean raises questions about what other surprises may await us as we explore further into the cosmos. The discovery of a subsurface ocean on Pluto presented a puzzle, sparking crucial inquiries. How could an object located over 4 billion miles away from the Sun, with temperatures plummeting to -380 degrees Fahrenheit or -228 degrees Celsius, host an ocean beneath its surface? Understanding the mechanisms within Pluto that contribute to its active geology became a pressing question. Furthermore, given the wealth of information gathered from Pluto, why are some astronomers advocating for the International Astronomical Union, or IAU, to reconsider Pluto's planetary status? The key to unraveling the mystery of Pluto's subsurface ocean lies in its historical context. According to a widely accepted theory, there was a long-standing belief in Pluto having a considerably cold inception. During the formation of the solar system, the protoplanetary disk, which is comprised of gas and dust, played a vital role in providing the foundation for planet formation. Similar to the majority of other planets, Pluto also took shape during the early phases of the solar system's evolution, approximately 4.6 billion years ago, in a region situated beyond Neptune called the Kuiper Belt. The Kuiper Belt is predominantly composed of icy materials like water ice, methane ice, and various volatile compounds. It is conceivable that different ices in this region collided and amalgamated over millions of years, which is gradually forming a larger celestial body comparable in size to Pluto. Additionally, owing to the significantly colder temperatures in this outer region of the solar system compared to its inner counterparts, these ices remained relatively undisturbed. Consequently, this led to Pluto having an initially cool commencement. Over time, the internal heat of Pluto would have caused the melting of some of its ice, giving rise to a subsurface ocean. This theory effectively explains the presence of Pluto's subsurface ocean. However, there is a twist in this narrative. About 2 years ago, a group of researchers aiming to scrutinize this hypothesis discovered that a cold start might not be the case for this dwarf planet. Instead, recent geological observations of Pluto's surface indicated that it might have commenced with a hot formation scenario. It underwent a swift and tumultuous formation marked by a series of substantial impacts, which reminiscent of the earlier experiences. But how did the geological characteristics observed by the New Horizons spacecraft contribute to our understanding of Pluto's formation? This can be explained through a commonplace phenomenon. The vibrational energy of a molecule is dependent on its temperature. Thus, when temperatures decrease and water freezes, the vibration of water molecules diminishes, leading to the development of a less dense crystalline structure. Following this principle, water expands as it freezes and contracts as the ice melts. To witness a demonstration of this, you can place a glass of water in the freezer and allow it to freeze. You will notice that the glass may break due to the expansion of the water. However, it's crucial to exercise caution and ensure supervision when conducting this experiment, as it can pose risks. Shifting our focus to Pluto, it becomes evident that if it initiated as a hot entity and then gradually cooled, its surface would have expanded. Consequently, this expansion should be noticeable in specific geological features on Pluto. Conversely, If Pluto had a cold initiation and then warmed up, its surface would exhibit indications of compression. The research team, upon closely examining the observations from the New Horizons spacecraft, was astonished by the revelations made on this distant world. Surprisingly, there were no evident signs of compression, while features indicating expansion were distinctly visible. This was noticeable in all of Pluto's impact craters, including those situated in the oldest terrains, which appeared elongated. The existence of a subsurface ocean also provides insights into the rapid formation of Pluto. In the scenario where Pluto had a turbulent beginning with successive large impacts, the heat generated by these explosions would have continually accumulated within the dwarf planet's interior. This process would have facilitated the maintenance of Pluto's internal ocean in a liquid state. To achieve this, Pluto must have formed swiftly, which is likely within a mere 30,000 years. Each impact would have acted akin to a small explosion, heating the surface where it struck Pluto. If Pluto had formed slowly, the surface would have cooled down before the next impact occurred. Conversely, in a situation of rapid formation with simultaneous impacts building upon each other, the surface would have become sufficiently hot to give rise to a liquid ocean. Furthermore, this concept aligns with a study proposing that Kuiper belt objects could have formed within a few hundred or thousand years. Irrespective of Pluto's formation process, current research suggests that its ocean is likely sustained by the heat generated from radioactive decay within its rocky core, which is situated beneath a dense icy shell. This study underscores the profound insights derived from geological observations of celestial bodies. Moreover, if the hypothesis regarding Pluto's hot start proves accurate, it could have meaningful implications for other dwarf planets in that region, including Eris, Makemake, and Haumea. Therefore, if Pluto formed rapidly and experienced intense heat, these neighboring dwarf planets might have undergone similar processes, potentially leading to the presence of oceans akin to Pluto's. Now, the issue at hand is whether we should reassess Pluto's classification as a planet. In 2006, the International Astronomical Union demoted Pluto from a planet to a dwarf planet. The IAEA's planetary definition necessitates that an object orbits the Sun which possesses sufficient mass for self-gravity to achieve hydrostatic equilibrium or a nearly round shape, and has cleared its orbital neighborhood. While Pluto meets the first two criteria, it falls short of the third. Since the return of the first images of Pluto by the New Horizons probe, some astronomers contend that Pluto deserves reclassification as a planet. They argue that the IAEA's planet definition is too arbitrary. According to them, a planet's classification should be rooted in its intrinsic properties rather than its dynamic relationship with other solar system objects. Under this perspective, Pluto unequivocally qualifies as a planet displaying a diverse surface with mountains, valleys, craters, and even a subsurface ocean. These characteristics suggest geological activity, a trait common to planets. Additionally, Pluto boasts a thin atmosphere and a moon system indicating sufficient gravitational force to retain these objects, aligning with planetary characteristics. What are your thoughts on this matter? Interestingly, the discovery of subsurface oceans not only enhances our comprehension of celestial bodies, but also introduces the enticing possibility of habitable environments beyond Earth. Subsurface oceans offer a shelter for life to flourish, shielding it from the perils of catastrophic impacts and harmful radiation exposure. This study proposes that Earth might not be the sole oceanic world in our solar system. Rather, numerous oceans could exist beyond our current understanding. However, validating these possibilities requires future observations, and only then can a conclusive decision be made. And that's it. Thank you for watching, and if you wish to support us, please check out the link in the description. Until our next cosmic rendezvous, stay curious, stay connected, and keep reaching for the stars with Spaceverse.